Hello dear students, let me begin the next lecture. In this lecture we will prove that by reversing the direction of a curve, the sign of the line integral changes. This is very important statement. The proof is very simple. The main task in the proof will be to find out the parameterization of a curve when its direction is reversed. Let me begin the proof. The proof is quite simple. I will prove this statement by two methods in which I will use two different parameterizations. In the first method, first suppose that we have a curve which is traced in this direction, and let me call the curve C, and this sense or this direction is the positive direction. We have not reversed the direction of this curve. Okay, and suppose that this curve C is parametrically given by r of t equal to x of t I unit vector plus y of t j unit vector plus z of t k unit vector, where the parameter t varies from a to b. So r of t is the vector which represents the curve C when t ranges from a to b. And in the proof we do not need x of t, y of t and z of t, so we can simply represent the curve C by the vector r of t, and then we can give the variation of the parameter t. So this is the parametric representation of the given curve. Now we will reverse the direction. The new curve is exactly the curve C, but it is traced in the opposite sense. So this is the new curve traced in the opposite direction. Let me call it the curve C prime. Now the question is how to get the parametric representation of the curve C prime. Okay, I have seen a number of textbooks on differential geometry in which the authors say that if you want to reverse the direction of a curve, you have to simply reverse the sign of the parameter in the parametric representation of the curve. Okay, so it means that the curve C prime is described by the vector r of minus t, which is equal to x of minus t I unit vector plus y of minus t j unit vector plus z of minus t k unit vector, and minus t ranges from a to b in this case. If we multiply this inequality by minus 1, the result is minus a greater than or equal to t greater than or equal to minus b. Okay, this can be written as minus b is less than or equal to t less than or equal to minus a. So it means that on reversing the direction, the range of the parameter becomes from minus b to minus a. What we call r of minus t, as it is the function of t, but we call it r star of t. So this is the parametric representation of the curve C prime. Okay, as a reference you can see the textbook on differential geometry written by Manfredo do Carmo, and section 1.3 final paragraph. In this paragraph it is stated that if you want to change the direction of a curve, then the parametric representation of the curve traced in the reverse direction will be the parametric representation of the original curve, but the parameter will be replaced with the negative times of the parameter. Okay, you have to change the sign of the parameter. Okay, let me move forward. Now consider the line integral of a vector field f over the curve C prime. this line integral is definitely equal to this one. This is the dot product of f with the differential of the parametric representation of the curve C prime. What is this equal to? Now we will involve the parameter t. Since in the case of C prime, t ranges from minus b to minus a, so lower limit of integration is minus b and the upper limit of integration is minus a, and f will be written as f of r star of t, and then dot product with dr star by dt times dt. So here we have just applied the definition of the line integral. Now we will calculate the derivative of r star with respect to t, and for this we will use a little bit of calculus. Dr star by dt is equal to the derivative with respect to t. R star is equal to r of minus t. So this is the derivative with respect to t of r of minus t. Okay, now what is this equal to? This is simply equal to the derivative of r with respect to t evaluated at minus t, and then the derivative of minus t with respect to t, which is equal to minus 1. So this is equal to minus dr by dt evaluated at minus t. Okay, here I have used a very basic principle of calculus by which the derivative with respect to x of f of ax plus b, this is equal to the derivative of f with respect to x evaluated at ax plus b multiplied with the derivative of ax plus b with respect to x, which is just a. So this rule is employed at this position. Now we will put the expression for dr star by dt into the integrand. We get this equal to the integral from minus b to minus a f of r star of t. R star of t is r of minus t dot dr star by dt, which is equal to minus times the derivative of r with respect to t evaluated at minus t times dt. The minus sign with the derivative can be taken outside the integral, so we will take it outside here. Okay, now we will replace minus t with t, so t replaces minus t, so it means that in place of dt we have to write minus dt, and when t is equal to minus b, then minus t becomes equal to b. Similarly, when t is equal to the upper limit of integration, that is minus a, then minus t becomes equal to a. Okay, so therefore in this case we have this integral equal to minus times, in place of minus b we have b, and in place of minus a we have a, and then f of r of, in place of minus t we have t dot dr by dt, and minus t will be replaced with t. Now this is simply the derivative of r with respect to t evaluated at t. So this is just dr by dt. So we don't need to write t here, and then we have dt, which is equal to minus dt. You may be thinking that why I have not replaced this dt with minus dt. Okay, all the first note that d by dt is simply the symbol for the derivative with respect to t. Actually, dr by dt evaluated at minus t is the derivative of r with respect to t evaluated at minus t. So it means that this is simply equal to r prime of minus t, which is the derivative of r with respect to t evaluated at minus t. Okay, so when we replace t with minus t here, this derivative becomes r prime of t, which is the derivative of r with respect to t. So it means that when we replace t with minus t, then dr by dt evaluated at minus t becomes r prime of t, which is equal to dr by dt. Very simple. Okay, and hence dr by dt evaluated at minus t is replaced with dr by dt when we put minus t equal to t. So hopefully you have understood this important point. Now we will move forward. Take this minus outside. We get minus time minus, which is plus integral from b to a f of r of t times dr by dt times dt. Reverse the limits of integration. Bring a downwards. If we make a as the lower limit of integration and b as the upper limit of integration, then we know from the basic calculus we have to put a minus sign outside. The integrand remains as it is, f of r of t dot product with dr by dt times dt. What is this integral equal to? This is simply the line integral of the vector field f over the curve C. So this is minus remains as it is. This definite integral is the line integral over the curve C of the vector field f. What was the left hand side? This was the line integral of f over the curve C prime. So we have proved that the line integral over the curve C prime of f is equal to the negative times the line integral of f over the curve C. This minus sign can be shifted to the left hand side so that we have this statement. So we have shown that on reversing the direction of the curve C, the sign of the line integral changes. Okay, and this was what we needed to prove, and we are done. Now we will prove the statement by the second method. This method is also very simple, and for this we have to consider again the curve C traced in this direction, and this curve is parametrically given by the vector r of t, in which the parameter t varies from a to b. So this point, which is the initial point, corresponds to t equal to a, and the position vector of this point is, if this is the origin, the position vector becomes this one, and this is simply r of a, and this is the terminal point corresponding to t equal to b, and the position vector of this point is r of b, obviously. Now we will reverse the curve. The direction is reversed. This is the curve C prime. Now we will find a parametric representation for C prime, and a parametric representation for the curve C prime is r star of t, which is equal to r of a plus b minus t, where t varies from a to b. Note that in this parametric representation, when we put t equal to a, then we get r of a plus b minus a, that is r of b. So it means that the initial point is this one. And similarly, when we put t equal to b, then we get r of a. So it means that on putting the maximum value of the parameter, we get the terminal point, which is r of a, and this point is this one. So it means that this parametric representation is correct. Okay, so hopefully you have understood this. Now we will move forward. Again, we need dr star by dt, and this is equal to the derivative with respect to t of r of a plus b minus t. Okay, now again we will use the rule, that is the derivative with respect to x of f of ax plus b is equal to the derivative of f with respect to x evaluated at ax plus b multiplied with the derivative of ax plus b with respect to x, that is just a. So use this rule, we get this equal to the derivative of r with respect to t evaluated at a plus b minus t multiplied with the derivative of a plus b minus t with respect to t, which is minus 1. So this derivative is simply equal to minus times the derivative of r with respect to t evaluated at a plus b minus t, which is simply equal to minus r prime at a plus b minus t. Now consider the line integral of f over the curve C prime. T varies from a to b for the curve C prime. So lower limit of integration is a, and the upper limit of integration with respect to t is b. F will be expressed as a function of r star of t times the derivative of r star with respect to t times dt, and this is equal to the integral from a to b f of r star of t is equal to r of a plus b minus t, a plus b minus t, and then dot product with dr star by dt. Dr star by dt is equal to minus times r prime of a plus b minus t, and then we have dt. Now to avoid the confusion in the next steps, I will replace t with u. Note that t is the variable of integration, which is the dummy variable. So therefore t can be replaced with some other variable. So I will put in place of t the variable u. Okay. So since we are only putting t equal to u, so it means that the limits of integration will not change. Okay. So lower limit of integration is a and the upper limit of integration is b. The integrand becomes f of r of a plus b minus u dot product with r prime of a plus b minus u. Since we have put t equal to u, so it means that dt is equal to du. Okay, now we will put a plus b minus u equal to t. On taking the differential, we get minus du equal to dt. Okay, so it means that du is equal to minus dt. Number one. Secondly, when we put u equal to the lower limit of integration, that is when we put u equal to a, then t becomes equal to a plus b minus u. In place of u we will put a, that is t becomes equal to b. So when u is a, then t is b. Similarly, when u is b, then t is equal to a. Now this integral becomes equal to minus times the lower limit of integration is now equal to b, that is when u is a, then we have t equal to b. So in place of u equal to a, we have t equal to b. So b is at the lower limit of integration and a is at the upper limit of integration, and then f of r of a plus b minus u is equal to t. Dot product with r prime of a plus b minus u, that is t, and then we have du, which is equal to minus dt. Bring the minus sign outside. This minus sign gets cancelled with the minus at the outside, and reverse the limits of integration. A becomes downwards and b at the upper limit of integration, and in this case we have to put a minus here. So we have completed the proof. This integral is simply equal to the line integral of f over the curve C, traced in the positive sense. So this was what we needed to prove. Hopefully you have learned and enjoyed the proof. This completes our today's discussion. Thanks for watching.